Okay, let's take a look at number 2, still in the calculator section. They give you the velocity, it's 3t squared minus 12t, and they tell you that it's moving along the x-axis, and this function is valid when time is greater than 0 or equal to 0, and at 0 it starts off at -6. So this is the position function. That's x of t. There's the position. This might be in meters, feet, whatever. It's not given to us at this time. And this over here is time. So initially this thing starts off down here at -6. So they want us to find the position at some time equals a. We don't know what time it is, but let's just remember that if we're given the velocity and we're trying to find its position, then we have to go up the chain, so we're taking the integral. So basically, if we take the integral of position, we get what? This will give us, or excuse me, if we take the integral of velocity, this will give us the position. And the position function, sometimes it's called p. In this case, it's x of t. So anyway, integrating this is no big trick. This would just be t cubed and minus 12t squared over 2 plus some constant, right? Well, simplifying that, you get minus 6t squared plus the constant. And this is x of t. Well, can you fix this c? Because that's important to do, especially when they give us some information. Well, they gave us a nice one. Time is 0. We plug in -6 right here and solve for our constant. So once you know the position function, of course that constant's going to end up just being what? Constant's equal to -6. So we have t cubed minus 6t squared minus 6. And that's in general for the position of this function at any given time. Well, what are we going to do with this is they want us to find out what is x of a. So that's, if that was a number, you would just plug in that number in the parentheses in for time. So in this case, you just plug in the letter a. So that's not too bad there. You probably get a point for just taking the integral, and so if I was adding up the points, you'd probably get a point right here for getting to this step, and then another point right here for coming up with the correct answer in this part. So speed. Alright, so speed has to do with velocity, right? Well, how is speed and velocity related to each other? Speed is the absolute value of velocity. So I guess we need to look at the velocity function to see if it's ever negative. So since this is the calculator part, we could put the velocity equation into the calculator and see what we get. So we have, let's see if we can clear this one out. 3t squared. So we have 3x squared minus 12x. And we need to look at this function. Let's zoom 6 on this and see what it looks like. And remember, we don't care about it when it's, I don't like that. Let's change this. We can see it. There we go. Alright. So this is velocity. Let me drag this over here. Make it bigger. There we are. So if this is velocity, this is the velocity curve. It's negative over here. Starting off, it looks like it starts heading, the velocity is negative, meaning it's heading towards the left. And then it becomes more negative, further and further away. And then the velocity starts to become positive right here. So it starts off going negative, changes to positive. So what do we need to do is we need to figure out how to split this up into two parts and take the absolute value of 1. We'll call this part A, set that into the absolute value, and then over here in part B, since it's already positive, we don't have to worry about that portion of it. So really on this part, since we know what the velocity function is, just remember that you're taking the absolute value of this whole function. Alright, if you put that in a calculator, then you would see what would happen. All these negatives would become positive. So that's just that question. They're just asking you, do you understand the speed and velocity, what their relationship is? Okay? Alright, part C says, what is the direction of the particle when it first starts? Okay, well, we just talked about that above. So at time equals 0, as soon as you begin, the velocity starts becoming negative, so the particle is moving towards the left. If this was an up and down problem, a vertical motion problem, then this particle would be heading down to begin with. And when does this thing turn around? Well, when does it turn around? Well, if the particle is negative all along this portion of the curve, still moving towards the left, and then when the velocity reaches 0, it changes directions. So you just need to factor this velocity out, set it equal to 0, and you could make some statement about the velocity changing from positive to negative to justify your answer, but that's a pretty easy one. And the next part says, when, if ever, is the particle at the origin? Well, in part A, you found the position, correct? And remember, this is a calculator section, so when it's at the origin, the position is equal to what? It's equal to 0, right? So if you set this equal to 0 and find its 0 values, then you should be in good shape. Alright, let's take a look at number 3 in the next video.